According to the National Electrical Code, the maximum allowable ampacity of number 4/3 SER aluminum wire is only 55 amps. Aluminum has higher resistance than copper, which means it carries less current for a given wire size. The number 4/3 SER aluminum wire has a conductor resistance of 0.169 ohms per 1000 feet, which is higher than the resistance of copper wire of the same size. This higher resistance results in greater voltage drop and heat generation when carrying current. The proper breaker size for number 4/3 SER aluminum wire is 50 amps according to NEC Table 310.15b16. Using a breaker size larger than the rated ampacity of the wire can be dangerous and lead to, firstly, overheating of the wire, which can cause a fire; secondly, damage to the wire insulation; thirdly, increased voltage drop, reducing the voltage available to the sub-panel; and fourthly, failure of the breaker to trip when a short circuit or overload occurs. It is recommended to use a 50 amp breaker when using number 4/3 SER aluminum wire for a sub-panel feed. When considering electrical wiring, it is essential to understand the properties of different materials and their impact on current carrying capacity. Aluminum, while being a cost-effective alternative to copper, has some distinct characteristics that must be taken into account to ensure safe and efficient electrical installations. The higher resistance of aluminum compared to copper means that for the same wire size, aluminum will carry less current. This is because resistance impedes the flow of electrons, generating more heat as current passes through. The National Electrical Code, or NEC, provides specific guidelines for the ampacity of various wire types and sizes to prevent overheating and potential fire hazards. Ampacity refers to the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. For number 4/3 SER, or surface entrance cable, aluminum wire, the NEC specifies a maximum ampacity of 55 amps. This rating is crucial because exceeding it can lead to dangerous consequences. The conductor resistance of a wire is measured in ohms per unit length, typically ohms per 1000 feet. For number 4/3 SER aluminum wire, the resistance is 0.169 ohms per 1000 feet. This value is higher than that of a copper wire of the same gauge, which translates to a greater voltage drop and heat generation along the length of the aluminum wire. Voltage drop is the reduction in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause appliances and equipment to function improperly or not at all. Heat generation is another concern, as excessive heat can degrade the wire insulation, leading to short circuits and fires. Therefore, selecting the correct breaker size for aluminum wire is not just a matter of convenience, but a matter of safety and code compliance. According to NEC Table 310.15b16, the appropriate breaker size for number 4/3 SER aluminum wire is 50 amps. This table provides ampacity ratings for various wire types and sizes based on their insulation and installation conditions. Using a breaker size larger than the wire's rated ampacity is a hazardous practice. Oversizing the breaker can have several detrimental effects. Firstly, it can cause the wire to overheat. When the current exceeds the wire's ampacity, the wire's temperature rises. If the temperature gets too high, it can melt the insulation, exposing the bare conductor and creating a fire hazard. Secondly, oversizing the breaker can damage the wire insulation. The excessive heat generated by overloading the wire can degrade the insulation over time, making it brittle and prone to cracking. Damaged insulation increases the risk of short circuits and electrical shocks. Thirdly, it can increase voltage drop. As mentioned earlier, aluminum wire already has a higher resistance than copper wire of the same gauge. Overloading the wire further increases the voltage drop, reducing the voltage available to the sub-panel and the devices connected to it. Reduced voltage can cause appliances to malfunction or operate inefficiently. Fourthly, it can cause the breaker to fail to trip. The purpose of a circuit breaker is to protect the wire from overcurrent conditions by tripping and cutting off the power supply. If the breaker is oversized, it may not trip when a short circuit or overload occurs, allowing the wire to overheat and potentially cause a fire. To summarize, using a 50 amp breaker with number 4/3 SER aluminum wire is crucial for preventing overheating, protecting the wire insulation, minimizing voltage drop, and ensuring the breaker trips in the event of an overcurrent. When working with electrical wiring, it is always recommended to consult the NEC and follow local electrical codes to ensure safety and compliance. These codes are designed to protect people and property from electrical hazards. Furthermore, it is important to remember that electrical work can be dangerous and should only be performed by qualified electricians who have the necessary training and experience. If you are not comfortable working with electricity, it is best to hire a professional to handle the job. In addition to selecting the correct breaker size, there are other factors to consider when using aluminum wire. These include using proper connectors and terminating the wire correctly. Aluminum wire expands and contracts more than copper wire with changes in temperature. This can cause connections to loosen over time, leading to increased resistance and potential overheating. To prevent this, it is important to use connectors that are specifically designed for use with aluminum wire. These connectors are typically made of aluminum and have a coating that prevents corrosion. When terminating aluminum wire, it is important to use the proper torque to tighten the connections. Over-tightening can damage the wire, while under-tightening can lead to loose connections. A torque wrench should be used to ensure that the connections are tightened to the manufacturer's specifications. Another important consideration when using aluminum wire is to apply an antioxidant compound to the connections. This compound helps to prevent corrosion and maintain a good electrical connection. Antioxidant compounds are available at most electrical supply stores. In addition to the points mentioned earlier, it's important to consider the specific application and environmental conditions when selecting and installing aluminum wire. For instance, if the wire is exposed to moisture or corrosive environments, it may be necessary to use a special type of aluminum wire that is designed to withstand these conditions. Furthermore, the length of the wire run should be taken into account. Longer wire runs will result in greater voltage drop, so it may be necessary to increase the wire size to compensate. Voltage drop calculations can be used to determine the appropriate wire size for a given application. These calculations take into account the wire's ampacity, length, and the load it will be carrying. It is also important to consider the type of insulation on the aluminum wire. Different types of insulation have different temperature ratings. The temperature rating of the insulation must be high enough to withstand the expected operating temperature of the wire. The NEC provides tables that list the temperature ratings for various types of insulation. When installing aluminum wire, it is important to follow the manufacturer's instructions carefully. The instructions will provide guidance on how to properly strip the wire, install connectors, and torque the connections. Failure to follow the manufacturer's instructions can lead to unsafe conditions. In addition to the NEC, local electrical codes may also have specific requirements for the installation of aluminum wire. It is important to check with the local authorities to ensure that your installation complies with all applicable codes. When in doubt, it is always best to consult with a qualified electrician. An electrician can assess your specific needs and recommend the appropriate type and size of aluminum wire for your application. They can also ensure that the wire is installed safely and in accordance with all applicable codes. In summary, using aluminum wire can be a cost-effective alternative to copper wire, but it is important to understand the properties of aluminum and follow the NEC and local electrical codes to ensure safety and compliance. Selecting the correct breaker size, using proper connectors, terminating the wire correctly, applying an antioxidant compound, and considering the specific application and environmental conditions are all important factors to consider. Furthermore, it is always recommended to consult with a qualified electrician if you have any questions or concerns. Remember, electrical work can be dangerous and should only be performed by those who have the necessary training and experience. By following these guidelines, you can ensure that your electrical installation is safe and efficient. Always prioritize safety when working with electricity. Turn off the power at the breaker before working on any electrical circuits. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the job. Electrical safety is not something to be taken lightly. Ignoring safety precautions can lead to serious injuries or even death. It is always better to be safe than sorry. In addition to the topics discussed previously, there are some additional considerations when dealing with aluminum wiring in existing homes. Aluminum wiring was commonly used in residential construction from the mid-1960s to the mid-1970s as a cheaper alternative to copper. However, problems with aluminum wiring began to surface, leading to concerns about its safety. The main problem with aluminum wiring is that it expands and contracts more than copper when heated and cooled. This can cause connections to loosen over time, leading to increased resistance, overheating, and potential fire hazards. Another problem is that aluminum oxidizes when exposed to air, forming a layer of aluminum oxide on the surface of the wire. Aluminum oxide is a poor conductor of electricity, which can further increase resistance and heat. If you have aluminum wiring in your home, it is important to have it inspected by a qualified electrician. The electrician can assess the condition of the wiring and recommend appropriate solutions to mitigate the risks. There are several options for addressing aluminum wiring problems. One option is to replace the aluminum wiring with copper wiring. This is the most expensive option, but it is also the most effective way to eliminate the risks associated with aluminum wiring. Another option is to install copper pigtails to the aluminum wiring connections. This involves attaching short lengths of copper wire to the aluminum wires using special connectors. The copper pigtails provide a more stable and reliable connection than the aluminum wires alone. A third option is to use CO/ALR connectors. These connectors are specifically designed for use with aluminum wiring and are designed to prevent loosening and corrosion. It is important to note that not all connectors are suitable for use with aluminum wiring. Only connectors that are specifically labeled for use with aluminum wiring should be used. When dealing with aluminum wiring, it is important to follow all safety precautions and consult with a qualified electrician. Aluminum wiring can be safe if it is properly installed and maintained, but it is important to be aware of the risks and take appropriate measures to mitigate them. In addition to the technical aspects of aluminum wiring, it is also important to be aware of the potential impact on your home insurance. Some insurance companies may not insure homes with aluminum wiring, or they may charge high premiums. It is important to check with your insurance company to see what their policy is on aluminum wiring. If you are planning to buy a home with aluminum wiring, it is important to have it inspected by a qualified electrician before you close the deal. The electrician can assess the condition of the wiring and provide you with an estimate of the cost to repair or replace it. This information can help you make an informed decision about whether or not to purchase the home. Aluminum wiring is a complex issue, and it is important to do your research and consult with qualified professionals before making any decisions. By taking the necessary precautions, you can ensure that your home is safe and that you are protected from the risks associated with aluminum wiring. Always remember that electrical work should only be performed by qualified electricians who have the necessary training and experience. If you are not comfortable working with electricity, it is best to hire a professional to handle the job. Your safety and the safety of your home are worth the cost. The information provided here is intended for general educational purposes only and should not be considered as professional advice. Always consult with a qualified electrician for any electrical work or concerns. Stay safe and be aware of the potential hazards associated with electricity. In conclusion, when dealing with number 4/3 SER aluminum wire, adhere strictly to the NEC guidelines, specifically Table 310.15b16, which dictates a 50 amp breaker for safe operation. Never exceed the wire's ampacity to prevent overheating, insulation damage, and potential fire hazards. Always use appropriate connectors and antioxidant compounds to ensure secure and corrosion-free connections. If working with existing aluminum wiring, consult a qualified electrician for inspection and remediation. Prioritize safety and compliance with local electrical codes to protect your property and well-being.